As for conclusion and recommendations, conclusion of our project is for the Sarir cement oil sourced from the Sarir cement oil is sourced. The Sarir cement oil rock is sourced from two or three rocks: the lower Cretaceous Nubian shale, upper Cretaceous ethyl evaporites, and upper Cretaceous silt shale. For the lower and upper Cretaceous silt shale and Nubian shale, that has been found in our area of study. And for the upper Cretaceous ethyl evaporites, this area or this member has been found, we saw this member back when we did the seminar. We studied the concession 47 before getting the CMA area, but we stopped that study because we hadn't sufficient data, so we changed the study of the area from the concession 47 to the CMA. Sarir cement has two oil generation during two periods: Eocene and Miocene. The original biogeometric surface map of the aquifer show a local low extending over the Sarir Misla complex. Misla complex, as my partner discussed before, is the Sarir trough and the Misla high. This suggests that migrations was controlled by Miocene. Miocene, that means the oil has been migrated all along by using the gravity. The cement trap is formed by a combination of normal faulting and tilting beneath the Cretaceous UC4 and conformity. These are the main faults in the whole Sarir, not in the cement, not in our project area. The faulting system has been in tilting beneath and Cretaceous UC4 and conformity. In our part of the cement study, we have the UC4 and conformity trap. The main reservoir divided into four members, as member 5EB, member 5EC, member 4, and member 3. The porosity for the reservoir ranged from 0.07 to 0.25. The water saturation of the reservoir ranges from 0.05 to 1. And the study area has 5 faults, ranging from fault 1 to fault 5. One is larger fault. Fault number 1 is located in the middle of the area. And the other faults are relatively small and located in the flanks of our project area. That's why we couldn't use the corner point grading. The total number of grids of the project area is 309,036 grid. This is the whole number of the grids in our 3D model, and 283 in I direction and 273 in G direction or J direction for each layer. This number of grids for each layer representing like approximately 273 and 283. The average velocity is the method used to make the velocity model in this study. As I discussed later, we had to take one value average because this is the only way we had to extract the velocity model with it. Due to the lack of data, the moving average method is used for building the property models. By using the volumetric equation, the stock tank original oil in the project area is 305 million barrels. As for recommendations, for further simulation studies on this project, more detailed fault interpretation must be applied to define the segments of the project area and the seal system between them, and finding out the values of traceability for each grid. As been shown before, we had to assume the 3D sim build. I said that the corner point is better in giving a real or ideal case for our 3D model, but we couldn't use it because the fault has limited numbers. So we need to make more faults in the area and close the area with borders, with faults, so you can use the corner point as for your gridding system. The grid system must be changed from simple grid to pillar gridding using the new defined fault model. To increase the oil production rate, further drilling should be focused particularly in areas on the project area. The areas which have good reservoir properties, porosity, permeability, and oil saturation. From well logs data, there is a reservoir potential above the main reservoir that should be studied, increase in oil reserves of the project area. As can you see from this log 292, there is a potential area above our area that it may have oil. Could be a good study to increase the reservoir, and as can you see represented on the depth of 7,800. This from the log of neutral and density, and the crossover of the shallow and deep resistivity, showing that this area has oil. This area is above our area of study 5AB. This is the most, it could be a good representative quantity of oil there because of its thickness. The second area that should be considered is showing here on the depth of 8,100. As for the third and fourth area, is small partition, maybe it's not economical to drill there. That's all for our project. I want to thank all the audience, the parents, the friends that showed today. Thanks the examiners. Thank you all for